guys, this is SyedaZaidi, and today I'm going to be talking about properties of logarithm functions. Now, this topic is 3.4 in pre-calculus, and it is you will need to know some rules and how, like, properties of how to solve them, because if you don't know these properties, you will be very much confused. So I'm here to guide you or to show you what kind of properties you will most often see when you're solving logarithm as like expressions or functions, and especially on graphing too. You will need to know when you're solving or trying to find like points and stuff. But therefore, we're just gonna get started on the properties of what you should know while you're solving. So these are mostly the three main rules you should know about. The product rule. So the product rule is basically, like log, so since b, this is actually b, but most likely log is kind of evaluated as log base 10, but sometimes they would change, in some equations they would change it to like log 16, log base 16, log base 2, but in most equations they mostly have log base 10, like the b would substitute into 10. But in this example, or in this in this example, it will just show as b for now. So basically it's log base b right here, and then rs. So rs, okay, this part is just like an equation, just to show you how it goes when you're doing product rule. So now this time you have to evaluate them, so kind of like spread them around. So it'd be like log br plus log bs. So it just kind of like expands throughout the equation when you're doing it, and it will, when you actually do the product rule, if you need to when you're solving the equation, it will help you a lot when you get to the answer. Now the quotient rule is log b and then a fraction which I cannot see. Where is it? R over s, right? So it's log b r over s equals to log br minus log bs. Now this time it's a subtraction. So you see how this one was multiplication? Since I think you should know this before, but when it's multiplication, it's always addition. But when it's a division kind of type, or like a fraction, it's always subtraction. So basically log b r over s equals to log br minus log bs. So it's kind of like the same thing as this one, but opposite. Very much opposite. Now the power rule. The power rule is very most common in some. So it's log br, and then they have an exponent of c equals c times by log br. Now this might be kind of confusing since some people don't know at first on how to kind of understand where it's going through, but this will help you solve it when you're doing the equation. It's just like showing you that you are trying to expand them. So since like the exponent will be as like a sum now, and times it by log base b, and then times it by r. So it just like kind of expands throughout and just explains what you need to do while you are solving the equation. So this is what I need to show you guys before I start showing you problems. So I hope you guys enjoy, and I will see you when I show you questions. Okay, so the first problem we're going to be doing, and in this problem, we're going to be explaining a lot, and this is kind of like a basic kind of equation, which you should know how to before you start solving complex equations or logarithm functions. So basically it says that write the exponential equation in logarithmic form. Now the logarithmic form, I underline this because logarithmic forms always involve logs. Now when you're trying, now this is an exponential form, okay? Let's just say expo, okay? Now the thing about this, it says that is to write the exponential equation. Now some people get confused. They're like, what is exponential equation? Now this equation that they gave you is the exponential equation. The goal here is to change it to the logarithmic form. Now for some of you could have understood on how to change it since you kind of know how to, but if you don't, I'm here to help you, and this is the great way to start it. So how I solve or how I think about this is that when it comes to log has always a base of 10. Every log has a base of 10 unless the equation or a problem changes into a 2 or a 3 or a 4. But most of the time the common log is log base of 10. Now, since log base of 10 is right here, right? The best way to actually figure out is that you need to look at the 4. The coefficient, the 4 is the coefficient, right? So the coefficient is always the base of log, all the time, every time. So example, this was 32 over 2/5. Now 32 would be the base of log. So let's exit this out and let's make it log 4. Okay, now there is an exponent of -2, isn't there? Now with this exponent, we're not going to talk about this right now. We're just going to leave it for now, and we're going to talk about the answer they got. So you see, if you look at a calculator, or if you solve it by yourself, you can see that 4 to the -2, or 4 times 4 is equal to 16, which is 4 squared. Now, this time it has a -2, which means it would be a fraction instead of a normal number. So since it's a negative exponent, we're gonna say that. So okay, now you should also put parentheses since it won't get you confused. But I put parentheses so it helps me understand where I'm at, because if I don't, then I'll be like, where did this 1/16 come from? So you're kind of multiplying 2 by log base of 4. So it'd be 1/16 in the middle. The answer is always in the middle all the time. After log base 4, after the coefficient, the answer is always in the middle. And then the answer, the equal sign after that, is the exponent. Always the answer. The exponent is always the answer. And in this kind of equation, not the actual, well, it is the actual answer, but it's not like it's just like a form how to do it in a correct way. So this is basically your answer. And you might think that, oh, this is kind of really confusing for me, how do you do this? Honestly, just practice over and over. It might be confusing because at first you're going to be looking at a different kind of equation. Example, if it was 32 over 2/5 equal to 4. You'll be like, oh my god, how do you do this? It's just the same thing, except this one is a fraction and this one is a negative. The same thing. Okay, now let's go to the next question. Okay, so this is the second problem, and this problem is require you to simplify the logarithmic expression. Now, on this problem, what you need to do is that you just need to look at the problem and kind of, analyze what is written on there. So you see how this is 3 right here. I don't know why it's kind of like that, but I'm really sorry about that. But this is 3. This is 3 right there, right? So 3 and 27, you can kind of see like a connection, or like a perfect number, And you can kind of see how it kind of, matches a little bit, what times 3 equals 27. And it just gives you questions about what will equal that, what will equal this, and just kind of just gives you questions, and it does make sense, right? So when it's asking you that means that it's a very easy problem, and that you should honestly solve it in seconds, because the 3 and 27 does make sense together, and 27 is a perfect number of 3. So how are we gonna solve this? Now, if you think about it. So, let's see here. So, 3 equals 27. Because 3 times 3 times 3 equals 27. So, if you do 3 times 3 equals... Let's say x for now. Now, if you think about it, 3 times 3 is 9 times by 3, which equals to 27. Literally. 9 times 3, you do the factor of 3 times 3, which is 9, and then times 3 again. And if you look at a calculator, or if you know already, 9 times 3 does equal 27. And which is basically your answer. So 27, that means that this is basically what it is. Okay, another problem. So this is the third problem, And this one says simplify the logarithmic expression again. And this one is now a fraction instead of a perfect number or instead of a normal number. So log 30 base of 32 times by x equals to 2/5. Now, if you're gonna see, again, ask those questions to yourself. What makes 2/5 equal to 32? What exponent does 32 equals 2/5? Now, if you think about it, you will like kind of see a connection between 32 and 2/5 if you're like looking at a calculator or a problem, or if you even, you know, calculate it by yourself or analyze it. So what you're gonna do first is you're gonna kind of see what does 32 to 2/5 simplify by, you know. So let's see. So if you learned in my last time, 32. If you learned in my last first example, I showed you how it changes to exponential form to logarithmic form. This is kind of like what it is, but except it's in logarithmic form instead of exponential form. So basically, it'd be kind of like, so let's see here. Since 32 2/5 equals 2x, okay, this is the exponential form of logarithmic form. So it's just the logarithmic form changed to the exponential form, just to show you guys what it's kind of telling you, or what it was showing you, what it looks like in exponential form. Since it's more easier, kind of, if you kind of like change your exponential form. So 32 2/5. Now, what does it simplify? Now, I know that 32 and 1/5 equals to the exponential of 2. Now, if you think about it, this is me simplifying. So when you simplify this, it will most definitely equal to 4. And honestly, that's basically it. That's honestly your answer right there. Because when you're simplifying it, or when you even, okay, if you use a calculator of 32 2/5, you will see that it will equal to 4. But if you want to show your work and actually be understanding of how to do it, you would try to simplify it more. And this is the only simplifying answer I could get into right now at the moment. But right, okay, sorry. So basically, 32 1/5 times by 2 equals to 4, which is basically the same thing as this, but simplifying it more. And this 4 is basically your answer for this equation.